Hi guys, I forgot to talk about the two concepts, that is the control flow and the sequence number that I told earlier. So just a quick gist on what is control flow and what is sequence number. So these two concepts are something that TCP can do, not HTTP. uh, Basically control flow is something like uh, basically TCP is stateful, and HTTP is stateless, meaning TCP knows whom they are talking to, and it maintains the connection. uh, right, and no, WebSocket also is based on TCP, so WebSocket knows whom they are talking to, and it opens the connection for a long time than HTTP is like a request response model, where you send a request, server sends a response back, and the connection is closed, and next time you send a request, it is something new. It doesn't maintain the old request state, so it is something new. So that is why HTTP is called stateless. And since TCP is stateful, it needs to know whether the data that it sent earlier has been received by the receiver. Uh, to explain more, to attain this, basically, uh, TCP uses this sequence number. So each time server sends a data to the receiver also has to send a acknowledgement packet that this data has been received, and based on it, it is going to send the data, the further data. So let's assume that a server is the supercomputer, and here we are with the laptop with 1 GB of RAM, and a Pentium processor. So pretty slow computer, right? But the server is pushing us like 500 MB per second of data, our because it is a supercomputer. Our laptop can't able to receive that much data, so most of the data will be lost. So that when transferring data through TCP uses this control flow, and the control flow is something that TCP just send like 1 or 2 MB. All is analogy, so whatever I'm saying is analogy. So if the server, that is supercomputer, is sending like 1 or 2 Mbps of data initially to the client, and the client will acknowledge that I have received like 1 or 2 MB of data in a certain amount of time, let's say like after 3 seconds or 4 seconds. So that server knows that this is the rate of data that receiver is going to receive. So I will stream the data, basically like 1 or 2 MB per second, not like 500 MB per second, because uh, the receiver is not able to handle it. And let's say if the receiver can able to send the acknowledgement for 1 or 2 MB data within a split of a second, like in a millisecond, then the server is going to ingest more data. Instead of 1 or 2 MB per second, it is going to send like 3 or 5 MB of data per second, because the server knows that okay, this receiver is able to handle more data, so I'm going to push more data. So and this mechanism is called sliding control flow mechanism, and this is implemented by TCP. So TCP as a protocol knows how to push the data from the server to the client by using this control flow. And there is one more thing called sequence number. Sequence number is nothing but since TCP is initially going to send some data and not wait for acknowledgement initially, so it doesn't know that whether the data is being received by the receiver or not. Let's say a sequence number starts from 1 to 10, and server is going to send those 10 packets to the client. Client should receive all the 10 packets. Let's say if the packet number 7 is lost, and the client just sent acknowledgement for just 1 to 6, and then 8 to 10. So the seventh sequence number is missing, so server knows that the client didn't receive the seventh packet, so it is going to send the seventh packet again. And using the sequence number, client also will handle the data. Basically it will send that after 6th, if the sequence number 8 is being received by the client, instantly client will send that I did receive the packet number 7, and server is going to send the 7th packet again, and using that sequence number, client will compile all the packets and then use the data. But HTTP is not like that. If the data is lost, it is lost. It is up to the client to request the data again. But TCP makes sure that the data all the packets are being received by the client. So how it achieves using sequence number for each packet. Uh, hope this is clear. Um, like about sequence number and control flow, and of course there's more to it, but on a high level, this is how TCP works. Thanks.